Hello everyone, this is Manny here. Today we're going to be talking about proving trigonometric equations. To start off, we're going to be talking about the different trigonometric identities, just some basic ones that you're going to be using in order to solve these kind of problems and prove them. We're going to be talking about Pythagorean identities, the three main ones. In addition, we're going to be doing some reciprocal identities, just basic identities here. And then we're going to be looking at some examples, some intermediate, some advanced. And I hope you find this helpful. Without further ado, let's get started. Alright, so these are some basic identities that you need to know. On the left side, you have the reciprocal identities, and on the right side, you have the Pythagorean identities. Now, these are just basic identities that you're going to be using quite often, most of the time. Now, you have to know that sine is the flip of cosecant, and hence sine x is equal to 1 over cosecant, and vice versa, cosecant is 1 over sine. You also have to know that cosine is the reciprocal of secant, and vice versa, so cosine is 1 over secant, secant is 1 over cosine. Same thing with tangent and cotangent, they're reciprocals of each other. Also, it's helpful to know that tangent is equal to sine over cosine, and hence cotangent is cosine over sine. The next, probably one of the most important identities is a Pythagorean identity. You'll be using that quite often as well. Three versions of the Pythagorean identity. You have the cosine sine version, the tangent secant version, and then the cotangent cosecant version. So just devote those to memory. They'll help you out quite a bit. Now we're going to be doing some examples. Okay, so we're going to get started on the trigonometric equations. Here we have a left side and a right side. Now what you want to do is you want to pick a side that you think may or may not be easier to solve. What you want to do is manipulate one side and get it to equal another side. Think of it as a game. You want both sides to match. So deal with one side, get it to match the right side. If you do, you win. Okay, so what we're going to do is we're going to look at the left side of this equation and we're going to try to manipulate that. Okay, so we're going to look at the left side here. Now notice that it is a difference of squares. Can you see that? If you look at it, the difference of squares is when you have something of the form a squared minus b squared. Okay, well notice that these are to the fourth, but that's okay. What we can do is rewrite it as cosine squared squared minus sine squared squared. And now this is our a, and this is our b. And if you have a squared minus b squared, recall that to factor that you have a plus b, a minus b. Okay, so there's a lot of algebra stuff that you're going to be doing in these equations. So I suggest review your algebra if you need to, and review your factoring if you need to. There's a lot of concepts here. Okay, so we can rewrite this as cosine squared squared minus sine squared squared. And therefore this is our a, and then this is our b. So therefore we're going to substitute in cosine squared t plus sine squared t, because now a is cosine squared, b is sine squared, and then times cosine squared minus sine squared. Now that we have that, notice that this is one of your Pythagorean identities here, cosine squared plus sine squared, and that simply becomes 1. So that goes away. Now you're left with, on the left side, cosine squared minus sine squared. Now we gotta force that to be the left side. So what we're gonna do is we need to make a substitution for cosine squared, right? Because on the right side we only have sine squared. So what we're gonna do is we're gonna use a Pythagorean identity again here. So remember that cosine squared plus sine squared was 1, and we're going to solve for cosine squared here because we want to substitute it in. So we're going to subtract the sine squared, leaving us with cosine squared is 1 minus sine squared. Now we can make a substitution there and substitute in for cosine squared. So that becomes 1 minus sine squared. And then don't forget to bring down your other sine squared. and then combine like terms. So this becomes 1 minus 2 sine squared. And notice how the two sides now match. Okay, so we have proved this, and I showed this with a little square, to show that I'm done with my proof. Okay, so we have another problem here. We're going to simplify the left side to make sure it matches the right side. Now we have a fraction here. Don't get scared of fractions. We need to combine we need to have the same denominator when we combine fractions, right? So make sure that you need to review how to combine fractions and algebra concepts, because you're going to need them for these kind of problems. So in this case, we're going to find the least common denominator. So the least common denominator is simply going to be the product of the denominators here, so sine and cosine. Okay, so notice that the first fraction here is missing a cosine. So we need to multiply top and bottom by cosine. Same for the bottom, it's missing a sine. So we're going to multiply top and bottom by sine. Okay, so we're going to rewrite this now. And then we're going to combine the two fractions under one common denominator here. Okay, so we have them under one common denominator. Now we're going to distribute this guy. Do the distributive property. So we're going to have sine theta cosine theta minus cosine squared plus sine theta cosine theta minus sine squared. Of course, all over sine cosine. Okay, so now notice that if we combine like terms, we have 2 sine theta cosine thetas and we have a minus sine squared and a minus cosine squared. What I'm going to do is I'm going to factor out a minus from that, and I'm going to get positive sine squared and positive cosine squared. And I did that for a specific reason, because it matches a Pythagorean identity. So if you look at this, this is going to be 1. So now we have 2 sine theta cosine theta minus 1 over sine theta cosine theta. Now we can go ahead and split these into 2 fractions again. And then you'll see that we're going to be closer to our answer. So if we split this to 2 separate fractions, those cancel out, and then we're going to have the minus 1 over sine cosine. So here we just split this into 2 separate fractions, there and there. And notice that and we're going to rewrite this here. So we have 2 minus, I'm going to rewrite this second part as 1 over sine and 1 over cosine. Those are the same thing. And then now 1 over sine, if you recall, that's equal to cosecant. And 1 over cosine is equal to secant. So I can replace those guys, and I have 2 minus cosecant and secant, which if you look at the right side on the original is the exact same match. It doesn't matter what order cosecant and secant are, because it's commutative property. So these match, so that means we have proved it. Alright, so here's the next problem. So here we have another fraction, and again we're going to deal with the left side. Now there's multiple ways of doing this problem. I'm going to try to do a way that seems relatively easy in order to make it look simple. Again, you can do it multiple ways, but I'm going to choose this way. So what I'm going to do is I'm going to replace cotangent with cosine over sine. Okay, so remember that cotangent is cosine over sine. So let's go ahead and rewrite this. And tangent is sine over cosine. Now what I want to do is I want to simplify the denominators here, right? So I want to combine, I want to get that to be one fraction and that to be one fraction. So notice that this is a 1 over 1. The least common denominator is sine. So I'm going to multiply this by sine, top and bottom. For this one, I need a cosine, so I'm going to multiply by cosine on top and bottom. Okay? So let's rewrite this. So now I'm going to combine them under one fraction in the denominator here. This is going to be sine theta for this one. Cosine. All right. Now you got to remember, how do you divide a number by a fraction, right? Because you have a numerator here, and then you're dividing by a fraction. So remember that this is the same thing as sine over 1 and cosine over 1. Employ KFC. You keep your numerator, you flip your denominator, and you change to multiplication. Okay, so I'm going to keep my numerator for this one, so I still have the sine theta over 1, right? I'm going to flip my denominator here, so this gets flipped. Same thing for the other fraction. I have cosine over 1. You keep that. You flip the bottom. And then you multiply. You change to multiplication instead of division. So you multiply across. So you're going to have sine squared Okay, so now these have the same denominator now, right? The denominators are the same, so we can combine them. So we're going to combine the numerators. All under one common denominator. All right, we're getting there. Now what I would say this here looks like a difference of squares. Remember from the very first problem, it was a difference of squares. A squared minus b squared is a plus b times a minus b. In this case, a is sine and b is cosine. So I'm going to factor this as sine minus cosine times sine plus cosine. And the reason I do that is because now I see that these cancel. So that leaves me with sine plus cosine, which is exactly what the right side is. Okay, so this may be hard, some ways are easier than others, but I would say, as long as you're okay and you're confident in your math, you should be able to get the answer. Although it may be a bit more steps your way versus another person's way. Okay? Alright, let's look at the next one. Okay, so I'm going to, again, do the left side, just because I like to do the operations here, right? So I'm going to distribute. I'm going to do a FOIL, right? So let's go ahead and FOIL that and see what we get. So I'm going to get cotangent squared times sine squared plus cotangent squared plus sine squared plus 1. Okay, that's gonna, so let's see here. We need to match it with cotangent squared plus 2, right? Well, I notice here, let's see. Okay, so let's try this. Let's try replacing cotangent with cosine over sine, but since it's squared, it's going to be cosine squared over sine squared. And then I see that they cancel, so that's probably a good thing. I'm going to leave this like cotangent squared only because I have a cotangent squared here, and I don't want to replace cotangent squared with something else because then it won't match, right? So I'm going to leave that there, and I'm going to leave these alone for now. Notice I get cosine squared, but then I see, oh, okay, I got a cosine squared and a sine squared. So according to the Pythagorean identity, that should be 1, right? So I'm going to replace that with 1. So now I have cotangent squared plus 1 plus 1. And here you go. Lo and behold, you get the right side. So this one wasn't that bad, but it could have been worse depending what direction you took it in. All right, last one for this. Let's go ahead and do the left side. So we're going to FOIL this. This is essentially a FOIL, right? Because you have squared. So don't forget, don't write it as cosine squared minus sine squared and be done with it. Because this is really the same thing as cosine minus sine times cosine minus sine. Okay, so that's a FOIL that you got to do. Okay, so you're going to get cosine squared minus sine cosine minus sine cosine minus sine squared. And similarly for the other side, I'm going to write it over here. You're going to distribute. So you're going to get cosine squared plus sine cosine plus another sine cosine plus sine squared. All right. So we're going to combine everything here. So it looks like we have a cosine squared here and a cosine squared there. So that gives us a total of 2 of them, right? So 2 cosine squared. We have 2 sine theta cosine thetas, which cancel out completely with these cosine thetas, right? So that cancels out completely, gives us nothing. And let's see. What else do we have here? We have a minus sine squared theta. Let's see. Oops, this should be a plus here. I apologize. Negative negative makes plus right here. So that should be plus. So now we have 2 sine squareds. So we'll just, instead of canceling them out, which I was about to do, we add them. Okay, so we have 2 cosine squared plus 2 sine squared. Now we're going to factor out a 2 from this, and we get cosine squared plus sine squared. Lo and behold, of course, a Pythagorean. I said that this was going to be quite a common identity, and this is going to give you 1. So 2 times 1 is 2. So 2 is equal to 2. So therefore, we have proved the identity. And that's all there is. It's pretty easy to get lost in these problems, but it's also a simple concept. Just use your identities and use your algebra concepts and you should be fine. Just think of it as a game. make one side match the other. Pick the side that you think may be easier to do, or maybe easier to prove, and go from there. Best of luck, and hopefully this helped you.